Hello everyone and welcome. My name is Jonathan Wood. I'm here from the BlockHack team to present on a high-level overview of blockchain. What it is, what Bitcoin is, what Ethereum is, and both myself and my partner Jeremy will be looking at the history of the space of blockchain, the philosophy behind the different implementations of blockchain, and what it all means, why it all matters to industry, to governance, to society, and to individuals. So to start off with, blockchain is a very complicated issue. It's a very complicated technology with a lot of different voices. So let's simplify all that. What is blockchain in the simplest of terms? Let's think about blockchain by first thinking about emails. Let's simplify it a lot. With emails, we send emails all the time, and those emails are written records of the transactions, the social transactions we have between each other. So let's say two individuals have email correspondence, they go to court over some business lawsuit, and they disagree about what the emails said. Today, we refer to that shared history to resolve the dispute over what was said. And right now, that shared history is ensured by centralized authority, such as Gmail or whatever the email provider is. But what if we lost the trust in that centralized authority? What if we no longer trusted this centralized shared record? What's another way that we can ensure that this shared history is both valid and accepted by all the parties so that we can resolve this dispute? We can do that with a public record. That's what the blockchain is in its simplest sense. It is a public record of all these transactions. So the way we can do this is, instead of sending just the email between the two of us, we could send it to everyone in the world, everyone who uses the same system as us. So there are thousands or millions of people receiving the emails, and each of them are keeping a copy. So now there are thousands or millions of these email copies around, and all of those can be compared to validate what the truth is. And we can have that validated shared history by comparing all of our records together. And the security of this is in the size of the network. The bigger the network is, the more copies we have available, then the more records there are to compare, and the more assured we can be that this is the valid truth. Thus, there's trust from transparency and scale. The bigger the network is and the more we share, the more we can trust that what we're sharing is accurate and true. This helps us resolve disputes, but it brings another issue, privacy. Now everyone knows what we're saying to each other in our emails. That's not, in most cases, that's not what we want. So we can encrypt the content. That's one way to solve this. Now the actual content of what's being sent to the messages is secure. Only the two people actually conducting the correspondence can unencrypt the contents, but everyone stores encrypted versions of the contents. So we can compare the encrypted version, and the two people can unencrypt it at any time. And so we can still have that shared history where everyone has the copies, but without knowing what's in it. But this still has the privacy problem of everyone knows who's conducting transactions. Everyone knows who I'm sending emails to, how many times I'm sending them, what time of the day I'm sending them, and I might not want that. So the way we can solve this is by making our email accounts pseudonymous. Instead of Jonathan Wood sending you an email, you'll see user x9534 sending you an email. So you can think of this pseudonymous key, this public key, as your public address. It's what everyone knows, but it's not associated with your own identity. So this way we can obfuscate who's actually in control of this account. But we still have a shared record of what that account does, and so we can know what the truth is behind that account, and we can resolve disputes. We still have that shared history, and now we have extra privacy. And I can still verify that I own that address without revealing who I am through a private key, a password. The password then can verify where the origin was and verifies who controls that address without revealing who that person is that controls it. So I still have access to my email, and I can still access all my emails, and no one else can access them. But now, without having a centralized authority, everyone has copies of all the encrypted data, and we have this shared history. Transparent, secure, and a private system of trusted exchange of anything. That could be emails. It could also be money. And so how does this system of this public, transparent, and decentralized system. It's decentralized because there's no one person keeping the record. There are thousands, millions, billions potentially of entities keeping records. How does this decentralized shared history relate to Bitcoin? For that, we have to look into the history of Bitcoin and what environment Bitcoin came out of. So we first go to the same question. What happens when we lose trust in authorities? In this case, in the case of Bitcoin, these authorities are our financial institutions. 2008 financial crash. The banks were closing, accounts were frozen, people didn't have access to their money. Austerity from governments and quantitative easing, printing money from central banks seemed completely ineffective. Individuals lacked access to their money, they lacked control over their money, and that was disheartening for many people. Many people lost trust in our systems. That is the situation from which Bitcoin arose, and the situation in which an individual called Satoshi Nakamoto released Bitcoin under the premise that it is money that you controlled. You had access to your account. You were the only one who had your private key, so a bank couldn't shut down your account. You were the only one who had access to it, and you can conduct it with transactions with anyone. Also, we're going to agree that we're not going to be able to print more money. So Bitcoin is limited to a fixed number of Bitcoin. So we have that definite amount of Bitcoin. And so now the ultimate premise is control goes back to the individuals. Bitcoin was also this better store of value. For example, in some countries like Venezuela, they have a huge problem of inflation because the government has taken a policy of quantitative easing, printing more money, and that inflates the value of existing currency. And so many people in Venezuela and other countries have moved their life savings to Bitcoin because it's a more assured place to maintain the value of their life savings. Other people have gained access to banking where they weren't able to have it before. In war-torn or chaotic places of the world where traditional banks won't offer services because it's not safe to open a branch, we can now offer digital cryptocurrency online that anyone can access anywhere. So you can store money, send it to other people, receive and send money, buy goods, receive payments for your business, all digitally without having those traditional institutions in place. It's also a more effective means of international transfers. Instead of taking weeks and paying hundreds of dollars for bank wires through our traditional financial system, we can send money across the world for cents in a matter of minutes or hours. And that's how billions of dollars are moving into India and other countries through remittances each year now. So that's what Bitcoin is. And up to now, we've been talking about public blockchains. That's when you think of Bitcoin, Ethereum, most of the other cryptocurrencies, you're thinking about public blockchains. But step back and make a distinction between private and public blockchains. And thank you for those joining us now. What's your name?
Carlos.
Carlos? Nice to have you, Carlos. Jonathan. So this distinction between public and private blockchains, Bitcoin and most other currencies that get hyped and get a lot of attention are public blockchains. So they're transparent, anyone can join them and participate. The records are shared and public, and no one can manipulate those transactions afterwards because you'd have to change the record on thousands of computers all over the world. So there's that extra trust, extra security from scale. So public is decentralization. Those two words should be synonymous when you think about blockchain. They're great because they're more transparent. There's this security from the scale. There's consensus between all the individuals. And decisions are decentralized. Decisions meaning how you determine the shared truth. No one person has control over that. That's distributed. Some downsides so far are that conducting transactions can be rather expensive. You have to pay for each transaction to fund the mining process, which we'll get into a little later. It can be slow, taking upward for quick peer-to-peer transactions, taking upwards of 10 minutes to validate a single transaction, and it's proven difficult to scale any of these public blockchains beyond a few thousand transactions per second. For comparison, Visa handles tens of thousands per second. However, there are a lot of strong open source communities researching these problems. And so there's a lot of activity, a lot of funding, a lot of money, and a lot of brains working on these problems. But those problems do remain. On the other hand are private blockchains. Some examples would be Quorum, Hyperledger, Ripple. Those are centralized. They're controlled by a company, and so less is known about them. They have less transparency. And in exchange for that, they gain more control of the system. So their advantages are they have lower costs. You don't have to pay those transaction fees to fund the mining to create consensus between decentralized groups. Instead, you have one actor or a small number of actors that are all known, and decisions can be reversed if they need to, like if you wanted to refund a bank transfer. So this is very similar to the institutions we have now, but there's an extra level of auditing. An extra level of oversight. So it's a step in terms of efficiency. On the downside, there is Singapore failure. If you hack the one centralized server, you take control of it. They're less transparent, less data is shared, and they're not distributed. So they are still concentrated in one place. There are, however, several large companies that are researching it. And most of their progress is kept private because it's trade secret, so it's difficult to compare the exact advantages of public to private blockchains. But those are two different philosophies that are important to keep intact. Private blockchains are controlled by one centralized institution. You need to trust the authority. But if you do trust them, you have that advantage of scalable, cheap blockchains. If you don't, however, public blockchains provide that trust without having to trust a single individual. And they have that checks and balances between thousands of actors competing against each other. So Bitcoin and other open source projects are examples of distributed ledger technology, DLT. Public blockchains stand for transparency, security, and individual control. They are a new technology and underdeveloped, and more research is going into them. Private blockchains are not distributed, but they represent an efficiency gain, not a new paradigm. So there's good and bad to each system. It's just important to know what paradigm are you in when you're talking about public or private. So with that distinction made, let's look into a few of the more key elements of Bitcoin, which have, because Bitcoin was the first Bitcoin blockchain, these have carried over into a lot of the other currencies. Mining is or proof of work is something you'll hear a lot with respect to Bitcoin. What that is solving the problem that cryptocurrency has that emails don't. With emails, you can copy it. So if there's many records around, that's okay. If they all agree, it's okay to copy your emails, copy that data. But you don't want to be able to do that with money. So how can we be assured that you spending the money you have actually have that money and it's not a forgery? So first, how do I prove that I have the money that I want to spend? This is actually relatively easy with blockchain because there's that shared record. Everyone knows all the transactions you've done before, so you can simply sum up the record of the past transactions to get your current balance. And then you know exactly how much money you have to spend. The more difficult problem is what's called a double spend attack. That's when, what if I want to buy $500 of goods from you, Amir, and spend the same $500 on you, Carlos, to buy something completely different? Now, either you know about the other transaction, and the reason you don't is because decentralized systems aren't instantly synced between each other. You have different nodes in different parts of the world, and it takes a little bit of time for that record to spread and for everything to get synced together. And in that time, I might be able to spend the same amount of money, the same money twice, and that's called a double spend attack. So proof of work gets around this by intentionally slowing down the transactions to allow all the computers and all the nodes to sync up together. They do that with what's called a toy problem, where the proof of work, computers that are the nodes, the different entities, the people keeping the records, are conducting this complicated computational problem. The problem itself, the computational problem itself, isn't valuable, except you have to solve the problem in order to validate the transaction. And that problem is constantly changed to make sure it always takes about 10 minutes, no matter how many people are working on it. So this way, it intentionally slows down the transactions so that we can ensure that that money is the only time that money has been spent. And we can synchronize the records to ensure that there's no double spend attacks happening. So Bitcoin Duplicate slides, fun. The disadvantage of this is that it costs a lot of electricity because you have to spend a lot of energy to run these computers to process these complicated computations and validate these transactions. To compensate miners for that, for spending all that money, they get the transaction fees, and that's where the expense of public blockchains come from, is paying these transaction fees to fund the miners, which ensure that the integrity of the money is kept up. So there's a lot of research to find alternates to proof of work. Proof of stake, sharding, proof of capacity, proof of time are some examples of those, which you can look into if you want. So that's what mining is and how it ensures that the integrity of this blockchain is kept intact. One other major event that a lot of people focus on is Mt. Gox. Mt. Gox was the first major Bitcoin exchange. It was the largest Bitcoin exchange in 2013. And it was a place where people can deposit their funds and trade Bitcoin and USD like a stock market. However, because all that was kept on a single platform and a single account, that account got hacked and Bitcoin crashed famously from about $1,200 to under $300. And that, at the time, looked like the end of Bitcoin. It was a failed experiment. Of course, it recovered afterwards. However, it's still unclear how that hack happened. What we do know, though, it was a hack of the exchange, not the blockchain. So the exchange was built on top of the blockchain. The blockchain itself, Bitcoin and most public blockchains have never been hacked. They're open source code that's reviewed regularly, and they're pretty rigorous. The vulnerability exists, though, for anyone building applications on top of it. Those are traditional systems that are still vulnerable to traditional attacks, and we should be aware of that. Another big feature of Bitcoin is whales. Since Bitcoin for a long time was very cheap, early investors who believed in it were very few, and they, as a consequence, own the majority of the Bitcoin. These are the people who were the first miners, the first people buying and trading it, buying at Bitcoin when it was less than $1, and so they are now millionaires and billionaires. However, this has created a bit of a problem where about 1,000 accounts control about half the Bitcoin. And so this is a feature that has happened in many other projects where a small number of early investors in projects that become big billion-dollar things like Ethereum, like Ripple, like Dash, like Monero, a small number of early investors control a majority of the resources. And that's great incentive for early innovation and early adopters to grow the community. That's how you have people dedicating their time because they're in at the early days. And if it gets big, if they commit their time and stay dedicated and it gets big, they will benefit hugely. Of course, there has caused some inequality. And the main worry of this is that one of those 1,000 people could manipulate the markets with little effort because they have such an outsized share. So that's a feature to be aware of. Another feature of Bitcoin and just the cryptocurrency community is forking. So as you can imagine, 2008 happens, Bitcoin comes around, some people are feeling very passionate about what Bitcoin is and what its purpose is. And they don't always agree. Because blockchains are open source, they can be copied. So if there's a disagreement between the founders or the developers of I want to go this way, we want to stay the course we're currently on, they can easily copy the code with some tweaks and make a duplicate of it. And that's called forking the blockchain. And this has spawned many very similar projects that are competing. It happens from disagreement of the projects or competitors who want to compete directly with a coin. They can copy the coin's code and come out with their own version. So Litecoin, Bitcoin Gold, Bitcoin Cash are all forks of Bitcoin, and there's many other examples of these. Of course, many of these have remained much smaller than Bitcoin because the benefit of it is in large part the network effect, because of how many people are actually using it. With that, I'm going to take a pause now, and if anyone has any questions, I'm going to step down a moment and turn over to my friend Jeremy, who will be going over Ethereum and some of the other projects in the space. But first, does anyone have any questions about what's been going on so far?
Just a comment. Is that when you talk about the private chains,
yeah,
you said that Hyperledger is a private chain, but as far as you know, they are under the Linux Foundation.
Yeah, Linux.
I think that they are developing the open source
They,
for that.
yeah. They are open source, yes. The Linux Foundation and many other companies are contributing to them. What I mean by private is not that they're keeping the code private, but when you run a Hyperledger blockchain, the blockchain isn't open for anyone to join. That instance of the blockchain, you can control who the nodes are, and so the control of the blockchain, the code base is public. That's open source. Access to the blockchain, if I take that code and make my own version, I can control access. So with Bitcoin, anyone can join it. Anyone can become a Bitcoin node or create an account. With a version of Hyperledger, access is restricted. And that's the difference between it's public access or private access, as opposed to open source versus proprietary code. Yeah, you are right that Hyperledger is an open source project though, and yeah. Yeah. Yeah.
I was kind of curious as to how ownership is defined over like a Bitcoin.
Mm-hmm.
So let's say I own a Bitcoin, like
Yeah.
how do I know that it's mine? And like,
Yeah.
like how does that work?
So we don't bother keeping track of Bitcoin, we keep track of receipts. So the blockchain is this record of all these receipts of transactions. And so to know how much funds you have or what do you have ownership over, we look at your account, your public address, and we don't know that you control it, but we know that this public address exists, and we can see all the transactions associated with it. So we can total up those transactions, see what transactions have you received and what have you sent. And we can see the difference of that and that's your balance. So I can see it, so I know you own this particular Bitcoin. If I can look past the records, I see a record of you receiving it, and there's no records afterwards of you sending it away. That means you still have that in your account. So tracking the receipts is how you tell that. Yeah. All right.
With a crash like Mt. Gox's, where would I go if I wanted to purchase Bitcoin and have a company that I can trust?
Right. So there's a few different options with that. With Mt. Gox, that when you keep your currency in their exchange, you're able to trade quickly. You have a lot of liquidity exchanging between Bitcoin and other currencies. You can always, that platform is where the vulnerability is because it's a centralized platform. It's a traditional web database, and it's vulnerable to all the traditional hacks with any website or with any database. Some way.
Thank you very much for introducing me, Jonathan. I'm Jeremy Govea, and along with Noah, we're working to create these workshops to just educate all of you guys about blockchain technology and all of its many benefits. Jonathan went over Bitcoin and its benefits in terms of being a decentralized currency. We're going to go over Ethereum. Ethereum is the second largest cryptocurrency. It goes by the term, its currency is called Ether. It's the coin of the Ethereum blockchain, and it's a different blockchain with a different purpose. It's meant to give people a platform so that people can create different programs. So whereas BTC was originally created for transferring money, Ethereum was created to allow anyone to build anything. One of the most noticeable creations which you may or may not be familiar with is CryptoKitties, which is something that allows you to buy a cat with Ethereum. You can incubate it, and essentially it turns into this whole cat trading platform where people are actually making money just by breeding kittens. But Ethereum uses a programming language which is actually has a wide array of documentation that you can learn. It's called Solidity. It allows developers to create these applications, and there's a special term for these applications. Ethereum calls them smart contracts. Now, smart contracts are, once you deploy one, copies of the program can be sit on the blockchain. So if you deploy an application, it is deployed across the blockchain, and thousands of computers all over the world have it. The advantages to this is that you have increased security. So these programs run autonomously. They're public, so anyone can confirm that they're running functionally. And these contracts, the benefits of the smart contracts is that it doesn't just apply to something like CryptoKitties. If you're talking about a business transaction, a contract that you want to make with someone, if you put this on a blockchain, it's readily available for anyone to verify. And if you ever have a disagreement over the terms of your contract, there's a timestamp right there. You are forced to deal with whatever you agreed to. Now with Ethereum, you have the advantage of something called a token. It's another innovation that's introduced. It is a representation of value, and it has to follow certain standards. The token can represent basically anything you want as long as it meets those standards. Now, the token allows for new economies in different products and services. It is more transparent, it's secure, and also creates a liquid economy. Now, there are two types of sort of standards. You have the ERC-20, which is a fungible token. Each token is identical to the next. It's useful for representing different types of currency. The other one is the ERC-721, which is non-fungible, so it has to be unique. It's good for unique items such as a house, a car, anything that there can only exist one of. And so that brings us to ICOs, which stands for Initial Coin Offering. Essentially, since they were released, everyone's been doing it. You can launch an ICO in any idea. This has a specific downside in that, well, the upside is buying tokens funds the research and development of any early stage project. So if you have a very great idea and you're trying to crowdfund it, kind of like if you were using Kickstarter or GoFundMe, you could launch an ICO, and if people like your idea, they can buy your token, they can buy into your company with Ethereum. Now, it's potentially lucrative, not just for the person that has this neat idea, but also for an investor. So as an investor, you get to go in from the ground up, and as the company grows or the product grows, the value of your investment increases. So a very interesting side to ICOs is investing. The most common method is either speculative investments or investing in utility tokens. And we'll be going over which one does which. Many investments are purely speculative, and tokens that do virtually nothing, there are tokens that do virtually nothing with no value. So that's one of the downsides of ICOs. Since it's a public blockchain, anyone can come up with any idea. With speculative investments, if you have to invest, it's acceptable if you're releasing a new form of currency with an innovative feature or benefit, like Monero, where that increases privacy, or a couple of others. But new currencies with new features run by dependable teams, those can be a good investment. A lot of the times it's hard to, well, you must be very wary of what's going on, because a very honest company that launches an ICO will have major press releases. They'll have, their code will be open source, so you should be able to verify that the progress that they're making, the money you've invested is being well spent. An advantage to investing in an ICO is that since you purchased their token with Ethereum, it's transparent. Any spending that they do, you'll be able to keep track of, and there's a lot more accountability. Investing in something. I don't know, some scheme. So one of the downsides is there are a lot of companies releasing a token just to take advantage of hype. This is one of the main focuses of the SEC when it comes to cryptocurrencies. They want to make sure that people are actually creating authentic products. And this is kind of where a lot of major press releases will sort of tell people to be wary of cryptocurrencies. But the advantages to this, I hope you'll see, is that you can come up with things like utility tokens, where the value is tied to a product or service. And additionally, the utility token doesn't just represent this product or service, it also enhances its value. So it's kind of it's a double benefit, because while the value of the token increases as the product or service grows, the product or service is also kind of, well, the value of the product or service is enhanced by the token itself. Yeah. So this is usually sold early on, and there's an early benefit to it. Like I mentioned before, if you invest in something like this, there's a lot of potential for it to grow. One example of an ICO is Tatiana Coin. Now this was started by the musician Tatiana, and the whole point of it was to fund the production of her album. Now if you were to, once the album was released, you received a discount with your Tatiana Coin, or you could sell the coin for greater profit as Tatiana became more popular. One of the things you got to keep out for is avoiding a bad investment. So you have to distinguish, how do we distinguish speculative tokens from utility tokens? As I mentioned before, this is resolved with more transparency. As a company that's more in the public eye is less likely to be a very risky deal where you're going to end up losing out on any money that you've invested in them. Open source code, which is very important, as I mentioned before, it allows the community to verify any progress that the company is making. As well, as I mentioned, with the public ledger. And although fraud is possible, it is extremely difficult to pull off. Now here we go into a couple of use cases that you can use blockchain for. One of the biggest ones is real estate, where you have heavily restricted information when you're dealing with transactions, housing records, title deeds. Most of this information is kept on what's called the multiple listing service. So the problem is a lot of this information is fragmented. It's in chunks. You have to go to different locations to try to pull whatever information you need. Let's say if you wanted to buy a house and you have to go through a real estate agent. The advantages to having something like this on the blockchain is because, well, title records are usually stored on the local level. There's usually a tedious buying and selling process. Imagine being able to buy a house and not having to go through a real estate agent. Or you can cut out as many middlemen as you need. So if title information was on a blockchain, it would be indisputable. In South America, for example, there are farmers in Mexico that hold properties to land that they bought, but corrupt government politicians will do whatever, if they're just feeling like it or if they have ulterior motives, they can just argue the right of the land and the farmer will usually end up losing it. If something like that, a public record, a deed was on a blockchain, it's verifiable and you can't question it. So this would lead to more secure sales. Like I mentioned, you'd cut out the middlemen and you'd reduce fraud or theft, especially with such a big investment as a house. Now, the other option is supply chains. So if we think about Costco or even a farmer, product moves to a wholesaler, which moves to a distributor, wholesaler, retail stores, and then to the consumer. There's a lot of points of contact, and inventory goes through a large process. A lot of the times, companies will account for missing products and things like that, but there are all these every company that that communicates with each other has their own inventory system. So there is a lot of overlap there, and also a lot of risk for losing product. So blockchain would offer transparency to records and transactions, which would lead to better business-to-business communication, really. I mean, if one company says they didn't receive their delivery from the manufacturer, if something like that record was on a blockchain, they could quickly show that the correct amount was sent through. So with such an inventory tracking system, you have a lot of advantages. You can reduce time delays, you can remove costs, and you can account for human error. There's also the potential for scalability. You can use this technology abroad with every single inventory management system across the world. There's also the chance for better security because it's on the blockchain. And there's also an increase in innovation. From personal experience, retail stores, any company that has to deal with inventory management systems, they will try to spend as little as they can. And when it comes to fixing those systems, usually what ends up happening is that those systems are outdated and they're never fixed. If something like this, if an inventory system was on a blockchain, you wouldn't have to deal with that. There would be a lot more innovation. People would always be looking for ways to improve because this is a system that is affecting everyone and everyone benefits from it. It's also an indisputable ledger, as I mentioned, and so it increases accountability, which is especially why, I mean, we trust each other to have integrity and be honest, but ultimately, if that's something you don't even have to account for, it's easier to make these deals, these transactions with different businesses if you yourself are part of one. Last but not least, it's also another big factor of blockchain is identity. So currently with social media, Snapchat, Instagram, Facebook, we contribute information freely. A lot of this information is monetized and used against us. We all know, I mean, if you're keeping up with the news, certain things that are going on with Cambridge Analytica as well as Facebook, a lot of these companies will try to take any information you have and just try to make money off of it. Imagine you lived in a world where you could make money off of your information. Imagine having an identity you can control, having these decentralized ID hubs where you can store all of your personal information, anything from your social security number, first name, last name, interests, favorite pet, whatever you want. And if anyone wants this information, you can give what you want to give. And that gives you more control, and we can live in a more free society because we have a choice in what we want to share. And that is the end of my presentation. Questions? I guarantee you I probably don't know as much as Jonathan, but I will do my best.
How did you find out about the Tatiana code?
Oh, Jonathan actually had written up on that.
Okay.
I remember Trey also mentioned it. It was a pretty interesting idea.
Yeah. I worked so that was my boss she has a startup out of New York called Crypto Media, helping do like marketing PR for.
It's not exactly cursive, no.
But yeah, I thought that was really cool that she did that. She has no clue about blockchain technology or anything. She just paid someone to do that for her.
Really?
But it worked out. So.
I mean, the fact of the matter is, it caught her interest, and really, that's.
Another artist is trying to do that too because a lot of artists have to partner with like labels and things like that take a large percentage of the profit from a song. Whereas if you do this, it goes straight back to the artist, and all the value is held with the artist, and none of it gets dispersed against like record labels or managers and things like that. What?
Which at the end of the day are just middlemen.
Yeah, exactly. Yeah, but blockchain will help us. It would enable us to be direct patrons of art that we like. So artists, painters, musicians, you can just basically they can crowdsource for what they want, and kind of how Renaissance artists had their patrons, we can crowdsource and support an artist whose art we appreciate. And then you honestly, one of the biggest things I'd really love blockchain, like a use for it, is getting rid of Ticketmaster. Because everyone, if you want to go to a concert, you have to pay like 3 times the ticket price if you don't get in like at the exact moment.
So this was the first in a series of workshops. This was the high-level one of what blockchain is. The next 3 workshops in the series will be technical workshops looking at developing Ethereum smart contracts and deploying that to the blockchain, looking at tokens and how to fork a blockchain and issue your own token, so you can become a millionaire, just not denominated in USD, and as well as Web3, MetaMask, and the UI of a blockchain. So designing a front end that anyone can easily interact with and take advantage of the blockchain without having to code it or know the nuts and bolts of the technical side of it. So user interfaces for the common user. And all of these workshops are leading up to an event May 5th to May 6th, BlockHack, which is the first of a series of blockchain hackathons we're hosting at the University of Delaware. These are open to anyone, and so if you want to go to www.blockhack.de, there we have details on all these workshops, as well as the sponsors who have their own blockchain platforms and other wonderful opportunities we have at the blockchain hackathon for meeting companies, networking with other developers, and learning from workshops and working together to produce blockchain applications, blockchains and platform and tools building on top of existing platforms. Win cool prizes and come have some fun while changing the world. So come out to BlockHack.